All right, parabolas day 2. So we just talked about these two equations yesterday. Y equals is the one that opens up or down. X equals opens left or right. So we're going to rewrite each of these equations in the vertex form, and we're going to find each of the following different pieces of information. So looking at question number 1 and 2, the first thing you want to do is, make sure it is a parabola. So we know these are both parabola equations because there's only one quadratic term for the variable x or y. And when I'm looking at it, I always want to figure out, so is it the variable x or y being squared? Whichever one is being squared, that means you're going to solve for the other variable. So in this case, the first one, the x is being squared. That means we're going to be solving for a y equals equation. So it's either going to be a parabola opening up or down. For the second equation, the y is squared, which means we're going to be solving for x, which means the parabola is going to be opening either left or right. So that means I want to get everything that is a y variable to the other side and keep everything else on the other side. So we're going to go ahead and rewrite this. So we have x squared minus 6x, and then I'm going to write plus blank minus blank because that's going to be my completing square portion. And then we have plus the 17 is equal to, and we're going to add the 8y to the other side, so equals 8y. If I was doing this equation over here, I would write y squared plus 2y plus blank minus blank plus 9 is equal to negative 4x. Now comes the part where we're going to complete the square, which we've been doing for all of the other conic sections. So this hopefully is getting easier. So looking at the first part, half my linear term squared. Where's my linear term? So we know that the linear term is the negative 6x. So negative 6, half of that we know is negative 3, and negative 3 squared is 9. So that means we are adding and subtracting 9. And so this is the portion that we are going to complete the square for, or factor. So when we put that in the factored form, we get x minus half the linear term squared, and then we have to combine the negative 9 and the 17, which is positive 8, is equal to 8y, and then the next step is to solve for y because we don't want that number in front. So of course we want to divide each term, remember terms are separated by addition and subtraction signs, by that 8. So we don't like to have all of this divided by 8. We actually put this in front as our a value. So this is going to be 1/8 x minus 3 quantity squared plus 1 is equal to y. So this is our equation. And we can see that for this equation, y equals, and the a value is positive, so we know this is going to open up. All right, so before we answer the other questions, let's go ahead and look at number 2. So this is the portion that we're going to be completing the square for. So our linear term is 2y. So half of 2y would be 1, and 1 squared is 1. So we're going to add and subtract 1. So if I factor this, now this is y plus 1 quantity squared. And then we want to combine these two terms here. So that's plus 8 equals negative 4x divided by negative 4 for each term. And we get negative 1/4 y plus 1 quantity squared minus 2 equals x. So this is an x equals equation, and the a value is negative. That means our parabola is going to open to the left. So let's go ahead and look below. So let's go ahead back to the first question. So we just said this one we know opens up, and we know it opens up because we know that our a value is a positive 1/8. The vertex in this case is, remember, your h and your k. So h here is 3 and k is 1. So the vertex is at 3, 1. The focus of this we can find after we find our p-value. So the formula to find this we use is, recall, a is equal to 1 over 4p. So we know our a value because that's in the actual equation. So we have 1/8 equals 1 over 4p. And to solve, we can go ahead and cross multiply. So 1 times 4p is 4p equals 8 times 1 is 8 divide by 4, and we get P is equal to 2. So remember that is the distance from the vertex to the focus and the vertex to the directrix. So the easiest way to figure out exactly where your focus and directrix are, actually to plot it on the graph. So we're going to go ahead and plot the vertex, which is at 3, 1. Now that I have my vertex, I know that my graph is opening up. So remember, your focus is always on the inside of your parabola. So if my p-value is 2, that means I'm going to count up 1, 2, and that has to be where my focus is because it has to be on the inside of my parabola, and the directrix is down 1, 2. And so the directrix is a horizontal line because remember, it doesn't cross through the parabola. So this is at y equals -1 for the directrix. And you can actually see where the focus is at 3, 3. And for this, we know that the axis of symmetry is what cuts the parabola in half, which is the parabola in half is going to be a vertical line at the x-coordinate of the focus always, which is at 3, so x equals 3. And remember that the latus rectum is going to be also called the focal width of our parabola. And so that's 1 over our a value, the absolute value of that. So in this case, we have 1 divided by 1/8, which is actually equal to 8. So that means from our focus, we can count right 4, 1, 2, 3, 4, and left 1, 2, 3, 4. And so the distance from this point all the way through the focus to this point is equal to 8. And so those are the only points that we need in order to graph our parabola shape. Of course, we could always find more, but it's not necessary at this point. And so now we have our equation, we have our graph, and we have all the pieces of information that we need. So let's go ahead and look at the second one. So the vertex here, remember that your H and your K are switched. So for this one, recall that this is your H and this is your K. Because remember, an X value is always an X value, a Y value is always a Y value. So if this is attached to the Y, that has to be the K. And if our A is on the outside, then that's our H. So for this, our vertex is at the point -2, -1. Because remember, it's always opposite of what you have inside the parentheses. So this was +1, and this over here was the -3. So we already said we know this opens to the left, and we know that because our A value is equal to -1/4, and it's x equals equation. So to find the focus directrix, we need to find our p-value. And so let's go ahead and do that next. So again, a is equal to 1 over 4 times p. So in this case, a is -1/4 is equal to 1 over 4p. Go ahead and cross multiply. Doesn't matter if you put the negative with 1 or the 4. I'm just going to put it with 1. So -1 times 4 is -4p is equal to 4 times 1 is 4. So divide by -4, and p is equal to -1. And so that's another way that you can tell this is opening to the left because your p-value is negative in this case. So a lot of times people will use absolute value bars here and then just do the distance, but I like to keep the negative because it tells me which direction I'm going. So over here, the p-value is positive, so I knew it went up. If I would have had a negative p-value, it would have gone down. So this tells me it goes to the left. So let's go ahead and plot the vertex at -2, -1. Now that I have the vertex, I know that the focus is going to be inside the parabola. And so in this case, that means we know we're opening to the left. So this would be left 1. So that's our focus. And then, of course, the directrix is a vertical line going this way. Now we want to actually draw the parabola using the focal width, or again, the latus rectum. So we have a is equal to 1 over the absolute value of 1 over a. So for this, we have 1 over -1/4, which is equal to 4. So from the focus, we're going to count up 1, 2, and down 1, 2. So the distance from here to here is 4. And then we draw our parabola shape. So we can see that our focus is at the point -3, -1. The directrix is at x equals -1. And now our axis of symmetry, what cuts the graph in half, is horizontal through the y-coordinate of the vertex, which is at -1. So y equals -1. And there we have our graph and all our pieces of information. All right, so let's go ahead and take a look at writing the equation given the different pieces of information. So in order to write the equation, remember that you have 3 variables. You have a, h, and k. So those are the 3 things that we need to find. So again, remember in general, x is equal to a times y minus k quantity squared plus h. And if it's y equals, we have y equals a times x minus h quantity squared plus k. So again, those are the 3 things we need to find given the information. So right here we are given the vertex, which is of course your h and your k, and the focus is at 0, 3. So let's go ahead and plot the vertex and the focus. So there's the vertex, and the focus is at 0, 3. So we know that the focus is always on the inside of the parabola. And so in this case, we can tell that means that this graph is going to be opening to the left. And that means we're using an x equals equation. So we already have our h and our k. We just need to figure out what the a value is. And so remember, the a value is equal to 1 over 4 times p. Recall that p is the distance from the focus to the vertex and also from the vertex to the directrix. And you can actually count on your graph. The distance here is 1, 2. That means our p value is equal to 2, so we can use that to solve for a. So because it's opening left, if you want to use -2 for your p value, that's fine. Or you could just use 2 and remember to make that a value negative because it opens left. So in this case, we have a is equal to 1 over 4 times -2, which gives me -1/8. So we get x equals -1/8 times y minus, in this case, our k value, which is 3, quantity squared, and then our h value in this case is 2, so plus 2. And so it didn't ask us to actually draw the parabola, but let's just go ahead and take a look at it real quick. So our directrix would have been here. And if I quickly graph the parabola, if our a value is -1/8, that means that our focal width is 8. So if I count up 1, 2, 3, 4, and down 1, 2, 3, 4, that means my graph would look like this. Okay, so let's go to the second question. Now for this one, they gave us the directrix and the focus. So the directrix is at y equals -5, and the focus is at 2, 1. So remember, the vertex is in between the focus and the directrix. So if we know this is a distance of 1, 2, 3, 4, 5, 6, then half of that is 3. So if I count down 1, 2, 3 from the focus or up 3 from the directrix, I find the vertex. So we know the vertex is at 2, -2. Again, that's your h and your k. We know this parabola opens up because the focus is always on the inside of the parabola and the parabola doesn't cross over the directrix. And so we have a y equals equation. And now we can go ahead and find our a value. So in this case, we know that the distance from the vertex to the focus is 3, or the distance from the vertex directrix is 3. The focus is going up, so I'm going to use a positive value for that. So A is equal to 1 over 4 times 3, which is 1/12. So y is equal to 1/12 times x minus 2, quantity squared, plus 2. Or sorry, minus 2 because our k is -2. So that gives us our equation, and that's really all we need, but we're going to go ahead and graph this just so we know how to graph it. So our focal width in this case is the absolute value of 1 over 1/12, which is 12. So from the focus to the right, we're going to count 6, and the left 6 from the focus. So the distance from this point all the way to this point is 12, and that gives us our shape of the parabola. And that's it.